There's a photograph I keep going back to. It was taken at 3:30 in the afternoon Universal Time on the 5th of July, which on the ground was 1:30 in the morning on the 6th, and it shows the western side of a storm's eye wall lit up by moonlight. A satellite called NOAA 20 caught it on the way past. The strongest storm ever to hit American soil, photographed by moonlight, about 6 hours before it arrived. It's a lovely image of an appalling thing, and I've not really got past that. So, the title is a bit of a fib, and I'd rather say so now than have you wondering. Nothing is on a collision course with anything tonight. This all happened. It's mid-July, the storm is gone, the recovery is underway, and we know exactly how it turned out. Which is, I'd argue, the entire reason this works as something to fall asleep to. We're going to wander through it. The geography, the physics, the forecasting, the week itself, and what's still going on out there right now. No particular order of importance. If you fancy more of these, there's a subscribe button somewhere. Before any of this is a disaster story, it's a geography story, and I think the geography is the bit that gets skipped. The Mariana Islands sit in the Western Pacific, and the numbers people use to describe where that is are the sort of numbers your brain slides straight off. Roughly 3,800 miles west of Hawaii, about 550 miles east of the Philippines. Those aren't distances in the way we normally use the word. That's not a drive. That's not really a flight, in the sense of a flight you'd book without thinking about it. That is a substantial fraction of an ocean. The chain is 14 islands and the total land area comes to something like 180 square miles. Not each, all of them, added together. If you're British, that's a bit smaller than the Isle of Skye. Scattered across a stretch of open water you could lose several countries in. Politically, it splits in two, which confuses everyone, including, I suspect, quite a lot of Americans. Guam is a US territory on its own. The other islands are the Commonwealth of the Northern Mariana Islands, which is a different US territory with its own government. Guam and Rota, the nearest of the northern islands, are about 40 miles apart. So you've got two separate territorial administrations, two separate power utilities, two separate emergency management structures, on islands you could see from each other on a clear enough day. Population-wise, Guam and the Northern Marianas together come to a little more than 210,000 people. Guam holds most of that at around 160,000. Saipan is the biggest of the northern islands with somewhere between 43,000 and 48,000, depending on which count you're reading. Tinian has around 3,500. Rota has about 1,800. And here's the thing I'd underline if I were doing this on a whiteboard, which I'm not, because it's late. Everything else in this story is downstream of those distances. When a transformer blows on Rota, the transformer does not come from a depot 40 minutes away. It comes from thousands of miles away, on a ship or a plane, and it comes on a schedule that was already fully booked before anyone needed it urgently. When a power crew is needed, the power crew is not local, because a place with 800 people does not maintain a standing army of linesmen. Every generator part, every roll of cable, every pole, all of it has to cross ocean. That's not a criticism of anyone's planning, it's just what an island is. I've seen people describe the Marianas as remote US territory in news copy, and it's technically true, but it's doing a lot of quiet work in that sentence. Remote from what exactly? They're not remote from each other. They're not remote from Asia particularly. They're remote from the place the help comes from, which is the specific kind of remote that matters when your roof is gone. Now, a fun detail, because we're here anyway, the Mariana Trench is right there. The deepest known point in any ocean on the planet, the Challenger Deep, sits just to the southwest of Guam, nearly 36,000 feet down. If you dropped Everest into it, you'd still have a mile of water on top. These little specks of land, with their 180 square miles between them, are essentially the tips of an enormous underwater mountain range, standing next to the deepest hole in the world. It has nothing to do with typhoons. I just find it hard to think about the Marianas without thinking about that. And there are the latte stones, great stone pillars with capstones on top, quarried and raised across these islands by the Chamorro people, centuries before any European turned up, used as the foundations for buildings. There are still standing sets of them. There's a whole quarry on Rota where you can see ones that were cut and never moved, sitting in the ground where they were carved, which is the sort of thing that stops me for a while whenever I read about it. Somebody's Tuesday, frozen. The people here have been on these islands for something like 3,500 years. The Chamorro on Guam and across the chain, and the Refalawash, the Carolinians, who arrived later on Saipan. This is not a place that was recently colonized by a weather forecast. It's a place with a very long, very continuous relationship with the sky above it, and that turns out to be relevant. But that's the map. 14 islands, 180 square miles, 210,000 people, an ocean in every direction, and a very, very long way from the warehouse. Right. Rota. On its own terms, because it deserves a bit of that before we do anything else to it. It's the southernmost of the Northern Marianas, and it's the one people go to when they've had enough. That's not me being poetic, that's roughly the consensus. If Saipan is the busy one, with the airport and the hotels and the traffic that occasionally counts as traffic, Rota is the one people describe as what Saipan used to be like decades ago. Slow. Green. Not much happening, on purpose. There are 2 villages. Song Song sits on a peninsula at the western end, tucked underneath a great flat-topped hill called Mount Taipingot, which everyone calls the wedding cake because that's what it looks like. Sinapalo is inland to the east, nearer the airport, laid out on flatter ground. That's it. That's the settlement pattern. 2 villages, 1 road system, a lot of jungle and limestone in between. It's got a bird sanctuary, it's got some of the better diving in the region, and a reputation among people who dive for being uncrowded, which in diving circles is roughly the highest compliment available. It's got the latte quarry I mentioned. It has, and I love this, a golf course. And here is the number that lodged in my head and hasn't left. Rota has 967 power customers, not 967 people. 967 accounts on the grid. Households, businesses, the school, the health centre, the lot. 967. That is a number a single person could read out loud in about 10 minutes. You could, with a decent afternoon and a comfortable pair of shoes, physically walk past every single connection on that island. I've read population figures for Rota all week and they hover between about 1,500 and 2,000 depending on the source and the year, and none of them landed the way 967 did. Population figures are abstract. A utility customer count is a list. Somebody has that list. It's a spreadsheet somewhere with 967 rows, and every row is a roof, which is, I think, why the island keeps getting described the way it does in the coverage. The Weather Network called it the least populous of the main islands. Other outlets rounded it to 1,500 or 2,000 or about 2,000 people. They're all reaching for the same idea, which is, this is small. This is smaller than you're picturing. Whatever number you have in your head for a Pacific island with 2 villages, it's less than that. Rota sits about 40 miles northeast of Guam, roughly halfway between Guam and Tinian, and for most of its recent history that position has been a mild inconvenience. It's the island you pass on the way to somewhere else. Flights are small. The seaport is modest and does the job. It has, historically, sat slightly out of the way of the worst of things, not through any protection, just through the ordinary arithmetic of a big ocean and small targets. Guam and Saipan and Tinian have all taken direct, catastrophic hits within living memory. Rota, less so. Not never, but less so. And then on the morning of the 6th of July, the eye went directly over it. Not near it. Over it. As far as anyone can tell from the record, Bavi appears to be the first Category 5 whose eye passed directly across Rota. The first time that specific thing happened to that specific island. On an island chain that has been keeping careful track of these storms for a very long time and has plenty of prior entries to compare against. I'm not going to do the dramatic thing here. I'm just going to leave that sitting where it is, because we've got a long way to go before we get to that morning and there's no sense rushing at it. That's the island. 2 villages, a wedding cake mountain, a golf course, a bird sanctuary, some stones somebody carved 3,000 years ago and never finished moving, and 967 rows on a spreadsheet. Hold on to that number, it comes back. Now, to understand July properly, you have to go back to April, so let's do that. Sinlaku formed on the 8th of April, 2026, which is early. Not impossible early, but early enough that meteorologists made a note of it. The Western Pacific runs its serious business from about July through October. April is the warm-up. April is not supposed to produce the strongest storm on Earth. It did anyway. By the 12th of April, it was southeast of Guam, and it had peaked as a Category 5 with 195 mile-per-hour winds. The Joint Typhoon Warning Centre's assessment of its absolute peak put it a shade under that, with a central pressure of 896 hectopascals. Whichever figure you take, it was, at that moment, the strongest tropical cyclone anywhere on the planet in 2026, and the strongest thing the Northern Hemisphere had produced in April since Typhoon Surigay back in 2021. Then it turned toward the islands. Landfall came on the 14th of April, over Saipan and Tinian, with the eye crossing both. It had come down off its peak by then, and hit as a Category 4 with sustained winds around 150 megawatt and recorded gusts reaching 125. Which sounds like a reprieve, and wasn't, for one specific reason. It slowed down. Sinlaku's forward speed dropped to roughly 5 miles per hour as it went over. 5. That's a walking pace. That's slower than you'd move through an airport. A storm that crosses at 20 miles an hour is a terrible afternoon. A storm that crosses at 5 miles an hour is a terrible day and a half, and it does something qualitatively different to a building than a fast one does, because materials fail on a clock. A roof that survives 90 minutes of a given wind speed does not necessarily survive 9 hours of it. Fixings work loose. Water finds its way in and stays. The load never comes off. Saipan International Airport recorded occasional gusts over 100 meti upeg for more than 9 hours. 9 hours. Peak gust of 130s is before the station stopped reporting data altogether, which is its own kind of statement. Down south, Guam International logged occasional gusts over 50 meps for 48 straight hours, from the 13th to the 15th. 2 days of the wind never really stopping. Over 20 inches of rain fell on Saipan and Tinian. Power went across both islands. Water went. Roads were impassable, not blocked in the sense of a fallen branch, blocked in the sense of debris fields and downed utility poles lying across the tarmac. Tin roofs peeled off and became airborne. Cars flipped. The hospital flooded. Saipan has one. It flooded. Reading the coverage from that week, the phrase that comes up over and over from officials is a variation on "we can't tell you yet." Bernard Villagomez from the Territory's Homeland Security Office told NPR that they still had a shelter-in-place order, so first responders hadn't been able to do a full damage assessment. That's the honest position, and I respect it. But it does mean the first 48 hours of reporting on Sinlaku is essentially a very long shrug from people who could hear things breaking and weren't allowed outside to look. It wasn't only the Marianas either. Before it got there, Sinlaku went over Chuuk in the Federated States of Micronesia and killed a person, with a fisher missing at sea. That happened first, and it gets less coverage than it should, so I'll mention it here. The numbers on the aftermath are genuinely difficult, and I want to be straight with you about that rather than pick the biggest one and run. Yale Climate Connections put total damage to the Northern Marianas and Guam at about $1.5 billion, and that's the figure most of the July coverage picked up and repeated. Wikipedia's page lists something over 458 million. Those are not close to each other. Damage estimates for disasters move around enormously, depending on who's counting, what they're counting, and whether they're counting insured losses or total economic impact. And the honest answer is that the final number for Sinlaku probably isn't settled yet. Most outlets in July were saying 1.5 billion, so that's the one I'll use, with that asterisk attached. The death toll runs to 17. 6 of those were crew on a cargo vessel that capsized near Pagan Island during the storm, which is one of those details that sits slightly outside the story most people tell about a typhoon. You picture the wind and the roofs, and you don't picture a ship in the dark 100 miles north with a crew on it. And then, for comparison, one more fact. The last time a storm hit that close to Saipan and Tinian with that kind of strength was Super Typhoon U2 in late October 2018. That's the storm everyone out there measures against. U2's the benchmark. U2 destroyed thousands of homes and put children into school tents. If you're on Saipan and you're over about 30, you have a U2 story the way people elsewhere have a story about a hurricane or an earthquake or a flood, and it's not a fun one. 8 years between U2 and Sinlaku. I've got a whole thing planned about U2 on its own at some point, because it's a remarkable and horrible piece of meteorology and it deserves better than a paragraph. 8 years between those two, then 82 days between Sinlaku and the next one. This isn't a storm section. This is the bit in the middle, which nobody covers, because there's no satellite loop of it. 82 days is a strange amount of time. It's long enough that the news has entirely moved on. The camera crews left in April. Sinlaku stopped being a headline within about a week, because that's how disaster coverage works. It's an event, and events end, and once the event has ended, the story is over regardless of whether anything has actually improved. But it's not long enough to fix anything. Not out here. Not with the distances we talked about. So what's actually happening across Saipan and Tinian through late April, May and June is a slow, boring, exhausting grind that produces no footage. crews working through a power grid that took a Category 4 across it, poles going back up one at a time, feeders getting energised, then tripping, then getting energised again. Water wells coming back on as the power reaches them and going off again when it doesn't. It's not dramatic, it's just relentless. And people are living in it the whole time. Here's the detail that got me. FEMA's distribution centre on Guam in the run-up to Sinlaku was stocked with approximately 1.1 million litres of water, 723,000 meals, 5,300 cots, 3,600 blankets, 4,200 tarps, and 78 generators. 42 more generators were already on their way to Saipan. 90 FEMA personnel were in place across Guam and the CNMI before the storm even hit. I love those numbers, and I mean that. Not because they're big, because they're specific. Somebody sat down and worked out that the correct number of blankets was 3,600. Not 4,000, not a lorry load, 3,600. Somebody has a model that turns a storm is coming to a place with roughly 200,000 people in it into a precise quantity of cots. That is an enormous amount of unglamorous institutional competence, and it's sitting there in a press statement that about 11 people read. But look at that list again, and look at what's on it. 4,400 tarps. A tarp is a roof. That's what that line item means. It means the plan, from the start, assumes that thousands of roofs will not be roofs anymore, and that the interim solution for those households is a sheet of plastic, and that this arrangement will be in place for a while. And a while here means through a wet season. The Marianas don't have a dry summer. July through October is the wet part of the year, and also the busy part of the Typhoon calendar, which is a genuinely unkind piece of scheduling. So the tarps that went up in April were going to be tested, repeatedly, by ordinary rain, for months, before anything with a name turned up. Living under one of those is the part that doesn't make the coverage. It's not dangerous particularly. It's just wearing. It's noise every time it rains, which is often. It's the constant low-level awareness that the thing over your head is temporary, and you have no control over when it stops being temporary. It's a generator you have to fuel, and fuel that costs money, and a power bill that, and this is a genuinely grim bit of timing, went up anyway. Guam's rate-setting body approved a fuel charge increase of nearly 6 cents in late June, taking it to 19.4 cents per kilowatt-hour effective the 1st of July. For an average household, that's about $58 more a month. $58 more, effective 5 days before the next super typhoon, on an island still fixing the last one. There's a comparison people reach for with this stuff, the one where our parents tell us how hard they had it back in the day whenever we complained about something growing up. And it sort of fits, except for the tense. This isn't a story anybody's telling their kids in 30 years. This was 10 weeks ago, and it hadn't finished. That's the state of things at the end of June. 2 islands part fixed. Poles up in some places and not others. Tarps holding. FEMA still around. Federal paperwork from April still moving through the system at the speed federal paperwork moves. Everybody tired. And a couple of 1,000 miles to the east, over water at about 30 degrees, some clouds are starting to organise. Nobody was worried about bevy on the 1st of July. There wasn't a bevy on the 1st of July. There was some convection east of Guam, which in the Western Pacific in July is roughly as newsworthy as clouds. That basin generates disturbances constantly. Most of them do nothing. They spin up a bit, they fall apart, they never get a name, and the only people who ever knew they existed are the forecasters whose job it is to notice. This is important context for what follows, because the story of Bevy is not a monster appeared out of nowhere. It's one of the many, many things that happen every week happen to have every single thing go its way at once. By Thursday the 2nd of July, it had a name and a warning centre paying attention. Jeff Masters and Bob Henson at Yale Climate Connections wrote that Tropical Storm Bevy was intensifying over the warm Pacific waters east of Guam and appeared poised to rapidly intensify into a dangerous Category 4 or Category 5 super typhoon that would affect the Northern Marianas and Guam on Sunday. They also noted it might bring severe impacts to Asia late the following week. Read that again because it's the 2nd of July. The storm is a tropical storm. It is not a typhoon, let alone a super typhoon. And 2 experienced meteorologists are already saying, in public, in writing, This is going to be a Category 4 or 5. It's going to be over those islands on Sunday, and it's probably going to hit Asia after that. They were right about all three. The model guidance that day was equally on the nose. The 6 UTC Thursday run of the HAF's A model predicted Bevy would be a Category 5 with 160 F-pull winds and a central pressure of 910 millibars by Sunday evening, making a direct hit on Tinian and Saipan. Now, the Tinian and Saipan bit is the one thing it got wrong, and I'll deal with that in a minute. But look at the rest. Category 5, around 160 millisievert, around 910 millibars on Sunday. From a Thursday, on a storm that at the time was a disorganized tropical storm several hundred miles out. I find that genuinely remarkable, and I think it gets buried because forecast was accurate is not a headline anybody runs. It's only ever a story when they're wrong. But the intensity call here was made 4 days out on a system that had barely started, and it was, if anything, slightly conservative. Some housekeeping on where the season stood. Bevy was the 4th typhoon of 2026 in the Western Pacific and the 7th tropical cyclone of the year. 3 of those 7 had already made landfall somewhere, and between them they'd already killed more than a dozen people. That's the tally before Bevy does anything at all. It had at that point been a busy and unpleasant year, and it was still only just July, which is to say the season proper hadn't started. The steering setup was straightforward. There was a ridge of high pressure to the north, and Bevy was tracking along the underside of it, moving generally west, expected to turn west, northwest as the pattern evolved. That's textbook. That's what these storms do. A ridge is essentially a wall, and the storm runs along it until it finds a gap or the wall moves. There was no mystery about the general direction. West, then west, northwest, into the island chain, then onward toward Asia. So by Thursday you've got a named storm, an accurate intensity forecast 4 days out, a well-understood steering pattern, and a target zone containing 2 islands that had been hit by a Category 4 11 weeks earlier, and still hadn't got all their lights back on. Everything after this is essentially just the atmosphere doing exactly what the physics said it would do, which is a phrase I quite like, because it's the least dramatic possible description of what was, by any standard, an extraordinary event. Nothing about Bevy was a surprise. That's the thing that stays with me. There was no twist. Nobody was caught out. The forecast said Category 5 Super Typhoon, Sunday, those islands. On Thursday, and then on Sunday, a Category 5 Super Typhoon arrived at those islands. The only real question was which particular island. Right, this is the tangent. I've been looking forward to this one, and I make no apology for how long it's going to take. A tropical cyclone is a heat engine. That's not a metaphor, that's a description of what the machine is. It has a fuel, it has a working cycle, it has an exhaust, and if you interfere with any of the 3, it stops working. Understanding the parts is the whole game, because once you've got them, every single thing that happened over that first weekend in July stops being weather and starts being arithmetic. The fuel is warm seawater, not the water itself, the heat in it, and specifically the water vapour that heat produces. Warm ocean evaporates. That vapour rises, carrying the energy it took to evaporate it locked up inside, and when it gets high enough and cold enough, it condenses back into liquid, and every bit of that energy comes straight back out as heat. That released heat warms the surrounding air, which makes it rise faster, which drags more air in underneath, which pulls more vapour off the ocean, which rises, condenses, releases more heat. That's the loop. That's the engine. It's the same physics as your kettle, run at a scale that would take a year of humanity's entire electricity output to match in an afternoon. Satellite observations put the sea surface temperature under Bavy at around 30 degrees Celsius, 86 Fahrenheit. That is bath water. That is water you would describe as actually a bit warm if you got into it, and it stretched for hundreds of miles in every direction that mattered. But here's the part that people miss, and it's the difference between a storm that fizzles and a storm that does what Bavy did. The surface temperature is not the number. The surface is a skin. It's a few meters deep. A big storm churns the ocean underneath it. The winds physically drag deeper water up to the top, mixing it. If the water 20, 50, 100 meters down is cold, then a strengthening storm digs its own grave. It stirs up the cold. The cold cools the surface beneath the eye. the fuel supply drops and the storm chokes on its own wake. The Western Pacific in early July had warmth running well below the surface, not a skin, a reservoir. Bavy could churn as hard as it liked, and it kept finding more of the same underneath. That's what essentially unlimited fuel means in practice, and it's the single most important condition of the three. Second condition, wind shear has to be low. Wind shear is the change in wind speed and direction as you go up. If the wind at 30,000 feet is blasting in a different direction to the wind at the surface, then a developing storm gets pulled apart. The top of the tower goes one way, the bottom stays put, and the vertical structure it needs simply cannot assemble. Shear is the great destroyer of tropical cyclones. Most of the ones that never amount to anything died of shear. Bevy had almost none in its development window, so the towers went straight up and stayed stacked and reinforced each other. Third condition, and this is the one people never mention because it's the least intuitive, the exhaust. All that air rising through the storm has to go somewhere. It arrives at the top of the troposphere and it has to be evacuated outward, away from the centre, or it piles up and the whole thing backs up like a blocked chimney. A storm with poor upper-level outflow simply cannot deepen no matter how warm the water is, because the air can't leave. When the outflow is clean and unobstructed in every direction, the internal circulation can spin up freely, and it does so fast. Bavy's outflow was excellent. Forecasters noted upper-level outflow developing away toward Japan that was actively enhancing its ability to intensify. Warm water down deep, no shear, clean exhaust. All three, simultaneously for about 2 days. The result? Bavy strengthened by roughly 100 miles per hour in 36 hours. Sit with that. In a day and a half, this thing added 100 miles an hour to its winds. It became a super typhoon in the early hours of the 4th of July local time, over water at 30 degrees, having been a disorganized tropical storm on the 2nd. There's a term for this, rapid intensification. The formal definition is an increase of at least 35 mph in maximum sustained winds within 24 hours. Bavy didn't nudge past that threshold, it went through it like a wall. But here's the bit that I think is the most interesting fact in the entire storm, and I'm going to say it plainly rather than build up to it. Every tropical cyclone has a theoretical ceiling. Given a particular ocean temperature and a particular atmospheric profile, there is a maximum possible intensity, a hard physical limit on how strong a storm could be in those conditions, if absolutely everything went perfectly. It's a real calculable number, and it changes with the environment. Jeff Masters worked it out for the water Bavy was sitting on. The maximum potential intensity was roughly 200 miles per hour. And when Bavy hit, it was remarkably close to it. That basically doesn't happen. Masters made the point directly. It's quite rare for a hurricane or typhoon to reach its maximum potential intensity, because every condition has to be perfect, and the atmosphere and ocean together are a complicated system where perfection is rarely achieved. Something always goes slightly wrong. A dry slot gets entrained. A bit of shear turns up. The eye wall replaces itself at the wrong moment. There's always a tax. Bavy didn't pay it. Not on the way in, anyway. It got very nearly the maximum the ocean was physically capable of giving it, and it happened to be standing over Rota at the exact moment it collected. That's not the atmosphere being malicious. It's not even the atmosphere being unusual, really. It's the atmosphere being extremely ordinary in 3 ways at once, for 2 days, which turns out to be the rarest thing of all. I keep thinking about the phrase, the atmosphere doing exactly what the physics said it would do, because that is all this was. There's no villain in this section. There's just water at 30 degrees going for a very long way down and nothing at all in the way. Here's something that gets presented as a crisis and is actually just Tuesday. The models didn't agree on where it was going. In the days before landfall, the American GFS model was putting Bavi's center over Tinian and Saipan, the exact 2 islands still fixing themselves from April. The European model had it further south, closer to Rota and Guam. 2 of the best numerical weather prediction systems humanity has built, fed largely the same observations, producing different answers about a storm 3 days out. Now, the way this gets covered is as a suspense device. Which island will it be? Nobody knows. Terrifying uncertainty. And I understand why, but I'd like to make the boring case instead, because I think the boring case is more interesting. The models disagreeing is the system working. A forecast is not a prophecy, it's a probability distribution, and the whole point of running multiple independent models with different physics and different assumptions is that Where they agree you can be confident and where they diverge you know precisely how much you don't know. The spread is information. When the GFS and the ECMWF part weighs by 40 miles on a track, that 40 miles is a measured, quantified statement about the limits of what's currently knowable. It's not the forecasters failing to know. It's the forecasters knowing exactly how much they don't know, which is a much harder and more useful thing. And crucially, for the people on the ground, 40 miles of disagreement changed almost nothing about what they should do. That's the bit that gets lost. Under the GFS scenario, Tinian and Saipan take the eye wall, and Guam and Rota get severe typhoon conditions. Under the European scenario, Rota and Guam take the eye wall, and Tinian and Saipan get severe typhoon conditions. In both cases, every single one of those 4 islands needs to be sheltered, boarded, and shut by Saturday night. The correct action was identical across the entire spread, which is why emergency managers weren't paralysed by it. They were never waiting for the models to converge because they didn't need them to. The official forecast on the 4th of July brought the centre very near Rota before passing between Guam and Saipan on Monday morning. Typhoon warnings went up for Guam, Rota, Tinian and Saipan. All 4, not the 2 the GFS liked or the 2 the Euro liked, all 4, there's a lovely wrinkle in here too. On the 4th, satellite imagery and other data showed a partial eye wall replacement cycle getting underway. Quick explanation, since we'll want it later. A mature, very intense storm sometimes grows a second eye wall outside the first one. The outer ring chokes the inner ring off from its inflow, the inner eye wall starves and collapses, and the outer one contracts to take over. While that's happening, the peak winds drop. You've temporarily got 2 half-finished eye walls instead of 1 very good one. Then, once the new one settles in, the storm often re-strengthens. It's a bit like a snake shedding a skin, except the snake gets slightly wider each time. The JTWC saw the replacement starting and said, in effect, this'll knock it down a bit. It'll stay a super typhoon regardless, and it may well re-strengthen on Sunday. That is exactly what happened. It dipped, it reformed, it came back up. And now the bit I really want to point at. The JTWC's landfall prediction was Category 5 with 165 mph winds. It arrived at 180. Think about how that gets talked about publicly. There's a permanent background assumption in weather discourse that forecasters exaggerate, that the number on the telly is padded, that they're covering themselves, that it'll be less bad than they said. It's practically a national pastime in several countries. And here's one of the most closely watched storms of the year, forecast 4 days out at Category 5 by 2 blokes writing for a climate newsletter. Forecast at 165 ms at landfall by the warning centre, and it turned up 15 miles an hour stronger than the official call. The error was in the direction nobody ever assumes it goes. I don't think that means much on its own. 1 storm, 1 forecast, and 165 to 180 is well inside normal error bars for an intensity call. But I think it's worth saying out loud once, because the forecast was slightly under is not a sentence anyone expects to read, and it did a lot of quiet work in what came next. This section is about sentences. That's it. No storm mechanics, no numbers to speak of. Just some writing, and why I think it's some of the best writing the American government produces. The National Weather Service issued an extreme wind warning for Rota. That's a specific product, and it's rare. It's not a typhoon warning, which is a forecast. An extreme wind warning is issued when catastrophic winds are actually about to arrive at a specific place within a specific short window, and it's built to be handled the way a tornado warning is handled, which is to say, immediately, without discussion. Here's roughly what it said. And I want to walk through it line by line because every line is doing a job. It opened by telling people this was an extremely dangerous and life-threatening situation, and to take cover now. Then, venturing outside can result in death from flying projectiles. Then, unreinforced structures will be destroyed. Then it added that nearly all trees would be snapped or uprooted, that power outages would last weeks to possibly months, and that much of the area would be uninhabitable for weeks, perhaps longer. Now look at what's not in there. There's no hedging. There's no could potentially. There's no in some areas residents may experience. The verbs are flat future indicative, will be destroyed, will be snapped, will last. That's a choice, and it's a slightly uncomfortable one for a scientific agency to make, because strictly speaking these are probabilistic statements, and the Honest Scientific Register is full of maybes. They drop the maybes on purpose. When you're 11 hours from winds like that, may result in, and will result in, produce different behaviour in a human being, and only one of those behaviours keeps them alive. There's no adjective doing emotional work. Nothing is monstrous or devastating or unprecedented. The strongest word in the whole thing is catastrophic, which is a technical term in this context with a defined meaning. Everything else is concrete nouns and physical outcomes. Projectiles, trees, structures, weeks, and there's no attempt to sound good. That's the bit I keep coming back to. Nobody workshopped that. Nobody added a rhythm to it. It reads like it was assembled from a checklist by someone with about 90 seconds to spare, and it is devastatingly effective precisely because of that, in a way that no amount of craft could improve. Death from flying projectiles is, I think, the single best phrase in it. Because the mental image people have of extreme wind is being blown over, being pushed, and that's not really the threat. The threat is that everything not bolted down has become ammunition, and a lot of things you assumed were bolted down are also now ammunition. A sheet of roofing tin at peak intensity is not debris, it's a blade. That phrase does more work in 5 words than a paragraph of explanation would, and much of the area will be uninhabitable for weeks, perhaps longer, is the other one. Because it's not describing the storm at all, it's describing the aftermath, in the warning, before the storm has arrived. It's telling you that the decision you make in the next hour is not about surviving the night, it's about the next several months of your life. That's an enormous amount of information to hand someone at speed. Compare that to the standard register of official communication about anything, ever. All the softening, all the "we would encourage residents to consider." Every institution in the world writes like it's afraid of being quoted, because usually it is. And then here's the NWS Guam office, writing, "Venturing outside can result in death at 2:30 in the morning," and putting their name on it. The response side had already moved too. Guam opened evacuation centres across the territory. The governor urged people to avoid travel and stay indoors until conditions improved. Emergency evacuations were carried out on the 5th. The American Red Cross had sent volunteers out on the 1st of July, 5 days ahead, before Bevy was even a typhoon, on the strength of a forecast. 90-odd FEMA staff already in the region because of April now repurposed. About 500 people ended up in shelters. That number is smaller than you'd expect, and I want to be careful with it, because it doesn't mean people ignored the warning. Most housing on Guam is concrete. Post-U2, post-Mawar, an enormous amount of building out there is poured concrete specifically because of storms like this, and a concrete house is a shelter. The people in the shelters were the people whose homes weren't, which after April included a lot of households living under those tarps. An emergency official in Guam put it plainly to reporters. There were many vulnerable communities across northern Guam, people living in substandard building materials, and what he was hearing from Saipan and Tinian was dire. The advice given publicly was specific and again unvarnished. Be in your safe location by Saturday night, because Sunday goes downhill fast. Get inside before the winds arrive. Don't go outside during the eye wall. When the extreme winds come, treat it like a tornado is coming and move to an interior room immediately. Honest, specific, urgent, and not once panicky. There's a difference between those last two that most communicators never find, and this lot found it under deadline. I've read a lot of government prose this week. That warning is the only thing I'd put in a book. Start here. For about an hour on the morning of the 6th of July, the sky over Rota was clear. Not clearing. Clear. The eye of Bavi came in and completely enveloped the island, and for roughly an hour there was calm air and daylight, and presumably an absolutely surreal quiet over Song Song and Sinapalo, and the golf course and every one of those 967 connections. The eye passed over around 8 in the morning, local. Rota is 14 hours ahead of the eastern United States, which is why so much of the American coverage of this reads as though it happened on Sunday night. It did, for them. On the island it was Monday breakfast. If you've never been in an eye, and I haven't, the descriptions are consistently unsettling. Birds get caught in there and circle. The sun comes out. The sea is chaotic. Waves arriving from every direction at once because they were made by winds pointing every direction at once. But the air above it is still. People go outside. That's the well-documented thing. and it's the thing every warning in the world exists to prevent. People go outside during the eye because it looks over, and with an eye wall this compact and this violent, the wall coming back is not a gradual thing. It's not a rising wind. It's an edge. You go from calm to catastrophic in a couple of minutes, and it arrives from the opposite direction to the one it left from, which means everything that was leaning one way for the last few hours now gets pushed the other way. Trees that survived the first half because they bent go over in the second half because they bent the wrong way. So, an hour of blue sky over 1,800 people, with the second half still to come. Right. The numbers, once, properly, and then we'll leave them alone. The Joint Typhoon Warning Centre assessed peak 1-minute sustained winds of 285 km per hour, 180 miles per hour, with a central pressure of 901 hectopascals, gusts as high as 215 miles per hour. FEMA cited gusts over 200. Rotor experienced the destructive winds of the inner eye wall, and it struck at peak intensity. That's the detail. It didn't weaken on approach. It didn't wobble. It arrived at its own ceiling and made landfall while it was there. Now, the Japan Meteorological Agency put Bevy at 205 km per hour and 910 hectopascals at the same moment. Those two numbers look like a contradiction, and they're not, and this is genuinely one of my favourite bits of meteorological trivia because it settles about 4,000 arguments in comment sections. They're measuring different things. The JTWC uses 1-minute sustained winds. You take the average wind speed over a single minute. The JMA uses 10-minute sustained winds, the average over 10 minutes. And because wind is gusty and turbulent, a 10-minute average is always going to be lower than a 1-minute average of the same storm. You're smoothing over more of the peaks. The rough conversion is about 0.88, so a 285 km/h 1-minute wind lands somewhere near 250 on the 10-minute scale. And the JMA's 205 is a further conservative call on top of that using their own analysis. Neither is wrong, they're different rulers, which is why the same storm gets called a Category 5 super typhoon in one bulletin and a violent typhoon in another, and why any conversation that starts with, well, actually the JMA said, is usually a conversation about arithmetic conventions rather than about weather. The pressure numbers are closer, because pressure is pressure. You're not averaging anything, you're just reading a barometer, or more realistically inferring the reading from satellite. 901 against 910. Both extraordinary. For scale, Typhoon Tip in 1979 remains the record at 870 hectopascals, and that's the number nothing has touched in nearly 50 years. The National Weather Service office in Guam and the JTWC both made the same assessment afterwards, and it's the line that ended up in every headline. Bevy became the strongest tropical cyclone on record to strike US territory. On record. Not this year, not this decade. Ever. Stronger than U2, which had been the benchmark out there since 2018. Stronger than Mawar in 2023. Stronger, in fact, than anything that's ever hit any American soil anywhere, which includes every hurricane that's ever come ashore in Florida or Texas or Louisiana in the entire instrumental record. And it happened to an island of 800 people at 8 in the morning on a Monday, and I'd wager a decent sum that most people reading this had never heard of it. Right. I want to double back on something because I've been quoting numbers at you all night and I've not once told you where they come from, and the answer genuinely surprised me when I went looking. Nobody measured any of it. Not directly. Not the peak winds, not the central pressure, none of it. Every figure I've given you tonight, every figure anyone gave anyone about this storm, is an estimate made by people looking at pictures. Here's the thing I didn't know until this week. In the Atlantic, when a hurricane is bearing down on Florida, there are aircraft that fly into it. The hurricane hunters, actual crews in actual planes, going through the eye wall and out the other side, dropping instruments that fall through the storm, radioing back pressure and temperature and wind on the way down. It's one of those facts that everyone half knows and nobody quite believes. There are people whose job is to fly into the thing. None of that happens in the Western Pacific, hasn't, for nearly 40 years. The last one was the 15th of August 1987. The 54th Weather Reconnaissance Squadron flew a mission into a storm called Typhoon Carry, came home, and that was that. Regular aircraft reconnaissance in the Western Pacific had been running since the 1940s, decades of crews flying into the biggest storms on the planet, and it just stopped. The reasoning was cost, mostly, combined with a fairly reasonable confidence that satellites had got good enough to manage without. So since 1987, in the most active tropical cyclone basin on Earth, the one that makes the strongest storms anywhere, The only tool has been the satellite. I find that genuinely remarkable. The Atlantic gets planes, the Pacific gets a camera. And I want to be fair about this because it's easy to make it sound like negligence, and it isn't. The satellite coverage out there is extraordinary. Himauri 9 sitting in geostationary orbit taking images constantly, polar orbiters coming over on their passes, microwave instruments that can see through the cloud tops to the structure underneath. It's not that they're guessing, it's that there's a difference between measuring a thing and inferring it, and everyone involved knows exactly which one they're doing. The method has a name and a person attached to it, which I like. It's called the Dvorak technique after Vernon Dvorak, who worked it out between roughly 1969 and 1984. And the principle behind it is so simple it sounds like it shouldn't work. Storms look like how strong they are. That's it. That's the insight. A tropical cyclone of a given intensity has a characteristic appearance from above. The shape of the cloud pattern, how tightly the bands curve, whether there's an eye and how clear it is, how cold the cloud tops are on infrared, how symmetric the whole arrangement looks. Dvorak went through years of storms where the intensity was known, because aircraft had been in there measuring and catalogued what each intensity looked like from space. Then he built a scoring system out of it. You look at the picture, you match it against the catalogue, you work through the rules, and you come out the other end with a number. It is, functionally, extremely rigorous pattern matching. A trained analyst looks at a photograph of a storm and tells you how hard the wind is blowing inside it, based on what storms that look like that have historically been doing. And it works! That's the mad part. It works well enough that they cancelled the planes. Now, the honest caveat, the one the people who do this for a living are the first to make. Without direct observation, the true intensity of a storm will never actually be known. Not is hard to know. Will never be known. That number is gone. It happened over open water, and nobody was there with an instrument, and the best anyone will ever have is a very good inference from a very good photograph. There are more tools now than there were. There's an automated version, the advanced Dvorak technique, which takes the human judgment out of the matching. There's SATCON, which blends estimates together and leans on microwave data from the polar orbiters. Between them, they're better than one analyst squinting at an infrared loop. But they're still, all of them, remote sensing. They're still inference. And they have known weak spots, which is where this circles back round to Bavy specifically. These methods struggle with small storms. They struggle with unusually large ones. They struggle with storms whose core is an odd size. And they struggle most of all with rapid fluctuations in intensity, storms that are changing fast. Have a think about what Bavy was doing that week. It intensified explosively. It went through an eye wall replacement, which is about the fastest structural rearrangement one of these things can do. Then it re-strengthened. Then later, it ballooned out into that enormous wind field. Small core, then rapid change, then large core. Bavy spent its entire life doing the four specific things the estimation methods are worst at. I'm not saying the numbers are wrong. The forecasters who produced them are extremely good at this, and there's no particular reason to doubt them. I'm saying that the confidence interval around this storm is wider than the tidy figures suggest, and that the people who issued those figures would tell you so themselves without any embarrassment at all. Which explains the thing that's been sitting slightly awkwardly since earlier. The two agencies giving two different answers for the same storm at the same moment. Part of that is the averaging convention, which we did already. But part of it is simply this. Two sets of expert analysts, looking at the same photographs, applying slightly different house rules, and arriving at slightly different places. That's not a scandal. That's what inference looks like when it's done honestly by more than one group. Here's a fun detail, and it's a proper one. In the 10 years from 1978 to 1987, the last decade of the planes, aircraft went into 14 separate typhoons in that basin, with a central pressure of 900 millibars or lower. 14 in 10 years in one ocean. That number is greater than every other recorded occurrence anywhere else in the world combined, across the whole of observed history. 7 of the 8 deepest tropical cyclones ever observed have been in that basin, including the deepest ever recorded anywhere, Tip, in 1979, and then we stopped flying into them. I keep turning that over. The single most prolific factory for extreme storms on Earth, the place that had produced almost every record worth having, and the last plane went in during the Reagan administration. Everything since, every Western Pacific super typhoon of the last 4 decades, All the big names, all the record claims, all the league tables people argue about online, sits on satellite inference. The rankings are real. They're just softer than they look. There's a coda to this, and it's very fresh. About a week ago, the American satellite people put out a notice that the manual Dvorak estimates for the Northwest Pacific, the ones done by an actual analyst by hand following Vernon Dvorak's rules, are being discontinued, effective the 10th of September this year. Users are advised to transition to the alternative products, which is to say the automated ones. So Bavi is one of the last major storms in that ocean that a human being sat down and hand-scored off a photograph. That era is closing in about 8 weeks, quietly, in a technical notice that almost nobody read. I'm not going to pretend that's a tragedy. The automated methods are good and getting better, and they don't get tired at 4 in the morning. But there's something in it. For nearly 40 years, the way we knew how strong the biggest storms on the planet were is that a trained person looked at them properly and said what they thought. And now that stops. And it stops on a Thursday, by memo. One more thing on this, and then I'll leave it alone. The reason any of it works, the pattern matching, the catalogue, the whole edifice, is that somebody in the 1970s and 80s had aircraft data to calibrate against. Dvorak could say, storms that look like this are doing that, because planes had been inside storms that looked like that, measuring what they were doing. The technique is built directly on top of 40 years of crews flying into the eye wall, which means the satellites are, in a sense, still living off that fieldwork. Every estimate out there today traces back through the rules to a decade when people went and looked. We stopped taking the measurements, but we kept using them. We just use them as a lookup table now. I don't have a tidy point to make about that. It just strikes me as a slightly odd way to know something. The last plane landed in 1987, and we've been quoting it ever since. Anyway, next time you see a confident number attached to a Typhoon, 165, 180, whatever it is, just hold it a little more loosely than the graphic wants you to. Somewhere behind it is a photograph, a catalogue of what storms are supposed to look like, and somebody's very well-trained opinion. Which is, when you think about it, a slightly astonishing thing to build a warning system on. And it worked. Everyone on Rota knew it was coming. 2 people were injured on Rota. That's where I want to start this one, because it's the smallest number in the whole story, and it's the one that took me longest to believe. 2 injured, not killed. On the island, the eye went over. We'll come back to why in a minute. First, the rest of the chain, because Bavi was enormous and Rota was only the bit under the middle of it. Guam sits about 40 miles southwest, and Guam did not take the eye wall. Guam took the outer part of a very large storm, and here's what that looks like. 12.64 inches of rain in a single day at the international airport. That's a new daily rainfall record for the station. Not a near record, a record. On an island where they measure rainfall in a way that suggests they've seen a bit of rain. Top wind gust of 111 miles per hour. Saipan, up at the other end of the chain and about 100 miles from Rota, also clocked a 111 ph gust, which is one of those coincidences that means nothing but sits oddly in the brain. To be clear about scale, 111 MiG is a Category 2 hurricane's worth of wind. That is a serious storm on its own terms in any other context. If that landed on the south coast of England, it would be the weather event of the decade, and people would still be talking about it in 20 years. Here it's the footnote, here it's what the edges did. The damage inventory across Guam, Rota and Saipan reads exactly as you'd expect, and I'll go through it anyway, because the specifics are more useful than the summary. Power poles and lines down, roads flooded and littered with debris, buildings damaged, a water distribution station on Rota damaged, which is a small phrase for a significant problem, because a water distribution station is how the island's water gets from where it is to where the people are, and if it's broken then having water in the ground doesn't help you much. The US Coast Guard had crews working the waterways around Guam and the Northern Marianas clearing navigation hazards. That's a phrase that hides a lot. A navigation hazard after a typhoon is whatever's now in the harbour that wasn't in the harbour before. Boats, containers, roofs, trees, bits of dock, anything that floats and anything that doesn't but is now sitting where a ship wants to go. You cannot bring aid in by sea until somebody has been out and found all of it, and finding all of it takes days. Andersen Air Force Base asked all non-essential personnel to stay off the base. The Port Authority of Guam suspended operations entirely. Schools shut, obviously. Flights stopped. Rota's Municipal Operations Centre put out photographs afterwards. Fallen trees mostly. That's what the pictures show. Trees. Everywhere. Across everything. Local authorities reported major damages, which was as specific as anyone could be at the time, because the communications had gone and nobody could get a full picture. Rota's mayor, once assessments started, reported that roughly half of all structures on the island had been damaged or destroyed. Half. And then, at the bottom of every single one of these reports, in a sentence that reads like an afterthought, because there's nothing else to do with it. No deaths were reported on Guam or the Northern Marianas. None. The strongest tropical cyclone ever recorded striking American territory went directly over an inhabited island, took the roofs off half of it, and killed nobody there. I want to be honest about my own reaction to that, which was straightforwardly not believing it, and going back to check 3 separate outlets. Fox Weather. No deaths reported. NASA's write-up. Extensive damage. No fatalities noted. Al Jazeera, NPR, the lot. It holds. 2 injuries on Rota, and that's the human cost on the islands. And there's a version of this story where that's a heartwarming line to end a section on, and I'd like to not do that version, because I don't think it's an accident and I don't think it's a miracle, and both of those framings do a disservice to the actual reason, which is the next section. But before that, one thing I keep noticing about this whole chapter, and it's not really about the storm. Everything in that damage list is fixable. Poles go back up, roads get cleared, roofs get replaced. It's expensive and slow and miserable, and it will take months, and in Rota's case, a lot longer than months. But every item on it is a thing that money and time and crews can undo. The number that can't be undone is the one that says 0. And it says 0. That's the whole ballgame, really. Everything else is logistics. So let me make the case, and then let me be honest about the holes in it. The case is institutional memory. These islands have been trained, not by drills, by repetition, by actual storms arriving regularly within the lifetimes of the people who live there, in a cadence that has made typhoon preparedness a normal part of ordinary life, rather than an emergency procedure that gets dusted off and half-remembered. Look at the recent record. U2, October 2018, a Category 5, the storm the whole region still measures everything against. Mawa, May 2023, a Category 4 that tore up Guam. Sinlaku, April 2026. Bavi, July 2026. That's 4 significant events in under 8 years, and I've left out the near misses and the ordinary typhoons that only did ordinary damage. Now think about what that does to a place. It means the concrete. Post U2, a huge amount of construction out there went to poured concrete because plywood does not work here, and everyone has watched plywood not work. That's a building code doing its job, and building codes are the least glamorous and most effective disaster mitigation ever invented. Nobody wins an award for a building code. It just quietly means that when winds like that turn up, most of the population is already inside something that will hold. It means people know what a warning means. When the NWS says get to your safe location by Saturday night, nobody on Saipan needs that explained. They've done it. Their parents did it. The phrase safe location is not jargon there. It's a thing every household has already identified, probably years ago, probably the neighbours, or the cousins, or the church. It means the emergency infrastructure is warm, not cold. FEMA was already there. 90-odd staff on the ground from April, a stocked distribution centre on Guam, the Red Cross sending volunteers on the 1st of July off the back of a forecast. None of that got spun up from scratch in a panic. It was already running. And it means, this is the ugly one, that people have already seen the alternative. U2 killed people. Sinlaku killed 17, including that crew near Pagan. The reason the warnings land is that everybody knows what happens when they don't. That is an appalling way to acquire a skill, and it is nonetheless the way this skill is acquired. Everywhere, in every hazard-prone place on Earth. Japan didn't learn earthquakes from a pamphlet. That's the case, and I believe it. The 0 is not luck. 0 is the output of a system. Forecast 4 days out, warnings written by people who weren't afraid of the words, shelters open before they were needed, concrete under everybody's roof, and a population that took it seriously because they have earned the right to be cynical about weather warnings and choose not to be. Now the holes, because I'd be doing you a disservice otherwise. Rota has 1-800 people on it. 0 is a statistically fragile number at that scale. I'm not saying preparation didn't do the work. It plainly did. I'm saying that when the sample is that small, the difference between 0 and 3 is often one badly placed tree and one person who made a slightly different decision about which room to sit in. There is no version of a Category 5 crossing an inhabited island where the outcome is fully determined by preparedness. Some of it is chance. Anyone who tells you otherwise is selling something. The honest formulation is, preparation loaded the dice enormously, and then the dice still got rolled and they came up right. Both halves of that are true, and the second half doesn't diminish the first. Second hole. 0 deaths on the islands is a real and remarkable outcome, and it is also not the same thing as 0 deaths. This storm has a death toll. 20 people in the Philippines, which we'll go through properly later on. It's just not where anyone was looking. Third, and this is the one I'd want to say to anyone tempted to make this a tidy fable, the absence of deaths is not the absence of harm. Half of Rota's structures are damaged or destroyed. That's people's homes. That's the second time in 3 months for a lot of families in that chain. Nobody died is the best possible news, and it is not good news. If you follow me, it's the floor. It's the minimum acceptable outcome, and they cleared it, and clearing it cost them everything else. I think the reason the 0 matters isn't that it's uplifting. It's that it's evidence. It's a data point that says the storm's intensity was nature, and the survival rate was a decision made in advance by people who'd thought about it. The first half of that you cannot change. The second half is entirely within human control, and always has been. That's not a comforting thought so much as a demanding one. Bavy left the Marianas, started falling apart, and became a bigger problem. Both halves of that sentence are true at the same time, and untangling why is the most useful thing in this entire script. Once it was past the islands, it did the thing we talked about earlier, grew a new eye wall outside the old one and swapped over. Same process as the partial one on the 4th, except this time it went all the way through, and the ring it settled on was a lot wider than the one it started with. The joint typhoon. Warning Centre's word for the result was gargantuan. That is not a technical term, I've checked. That is a bloke at a warning centre looking at a satellite image at some unsociable hour and reaching for the biggest word available to him. And the Fox Forecast Centre put a number on it. Bavy's wind field ranked in the top 3% of all Western Pacific typhoons over the past decade. The top 3% by size. In the basin that makes the biggest storms on the planet. Over 10 years. And its maximum sustained winds were dropping the whole time. By Thursday it had been downgraded from super typhoon status, still carrying 114 piastres de Cespe sustained, according to Taiwan's Central Weather Administration. The JTWC had forecast shear rising to 20 to 25 knots on the Tuesday, expecting considerable weakening from Wednesday, dropping it toward Category 3 with about 20 mph winds by Friday the 10th as it approached northern Taiwan and Japan's Ryukyu. So on paper, it's collapsing. The category number is coming down. The headline wind speed is coming down. If you were following this on a news ticker, you'd have watched it go from Category 5 to Category 4 to Category 3 and reasonably concluded that the threat was receding. Yale's read was the opposite, and they said so at the time. The winds would be weaker when it hit Asia, but Bevy would be expanding greatly in size, bringing widespread storm surge, flooding, rainfall and damaging winds. Here's why, and it's simple enough once someone says it out loud. The category number measures one thing. 1. The peak sustained wind speed somewhere in the storm, usually in a ring a few miles across. It tells you nothing about how wide the storm is, nothing about how much rain it's carrying, nothing about how fast it's moving, nothing about the terrain it's about to hit. It is a single scalar describing the worst wind in the worst place, and we've built our entire public understanding of these things on top of it. Now think about what actually kills people and wrecks places. Storm surge scales with the size of the wind field, not just its peak. A surge is water piled up by wind pushing on the sea over distance and time. A compact, ferocious storm pushes very hard on a small patch of water for a short while. A sprawling 120 centimeters storm pushes moderately hard on an enormous patch of water for ages and moves considerably more water inland. The gargantuan one wins. Rainfall scales with size and speed, not with peak wind at all. The total water that falls on a place is roughly how much moisture the storm is carrying over that place multiplied by how long it sits there. A huge, slow storm at Category 1 will drown a region that a compact, fast Category 4 would merely batter. Every flood disaster you can name from a tropical cyclone in the last 20 years follows this rule, and almost none of them were about the category. Inland reach scales with size. A small storm dies at the coast. A big one carries its rain 300 miles inland to places that have never thought of themselves as coastal and don't have the drainage or the habits for it. And the number of people expose scales with the width of the thing, obviously. A storm twice as wide crosses twice as many towns. So what Bharvi did, in the space of about 4 days over the Philippine Sea, was trade the one variable that gets reported for 4 variables that actually matter. It gave back peak wind, the number on the ticker, the number in the headline, the number that determines whether people take it seriously, and it bought size, moisture, reach, and exposure. The ticker said the threat was receding. The threat was, in every meaningful operational sense, growing. I find this genuinely maddening, and I don't think it's anyone's fault exactly. The Saffir-Simpson scale measures wind damage potential to structures, and at that job it's fine. It was just never meant to be a general-purpose measure of how bad a storm is, and it got adopted as one anyway, which is why downgraded to Category 3 can sound like good news at the exact moment a storm becomes lethal to the largest number of people. Anyway, Bharvi crossed the Philippine Sea, getting flabbier and less impressive by the hour, and every serious person watching it got more worried rather than less. They were right to. Let's talk about the Habagat, because you can't understand this bit without it, and almost no coverage bothers. The Philippines has 2 monsoon seasons. The one that runs roughly June to September is the southwest monsoon, and locally it's called the Habagat. It's a seasonal wind system, a great persistent flow of warm, wet air coming up out of the south and west across the archipelago, dragging moisture off the South China Sea and dumping it on the western sides of the islands. It's not an event, it's a state. It's the weather, for a third of the year. It's why the rainy season is the rainy season. The Habagat on its own is perfectly capable of causing floods. It does, most years. It's a known quantity and people live with it. Now put a very large low-pressure system a few hundred kilometres to the east. A tropical cyclone is, among other things, an enormous vacuum cleaner. Air spirals into it from every direction across a vast area. So if you park one out in the Philippine Sea, it doesn't just do its own weather. It grabs the existing monsoon flow and accelerates it. The Habagat gets pulled toward the storm, which means it moves faster, which means it hauls more moisture, which means the rain it was already going to deliver to the Philippines becomes considerably more rain, delivered harder, over a longer stretch of hours. And this happens without the storm coming anywhere near the country. The eye wall, the record-setting bit, the part every headline was about, the part that put its name in the record books, never got within several hundred kilometres of the Philippines. Not once. The archipelago was never in the cone. The typhoon didn't hit the Philippines in any sense that a forecaster would recognise as hitting. It was given a name there anyway. Bharvi was still outside the Philippine area of responsibility when Pagasa, the National Weather Service, assigned it the local name in day. That's their convention. Storms that matter get a local name, and it mattered before it was inside the boundary, which tells you they'd already worked out what was coming. They raised Tropical Cyclone Warning Signal number 1 over the northeastern portion of Cagayan, then extended it over the whole province. Signal number 1 is the lowest signal there is. It's the mildest thing Pagasa can issue. Here's what happened. As of 8 in the morning local time on Monday the 13th of July, 20 people were reported dead across the Philippines. 16 more were missing. About 654,000 people were affected nationwide. Around 2,500 people were in evacuation centres. Flooding, landslides, damaged houses, roads and bridges cut, seaports disrupted. The National Disaster Risk Reduction and Management Council was still validating most of the casualty reports at that point, which is the standard and correct caveat. Early numbers in the Philippines move as verification catches up, and they move in both directions. Some other counts that week ran at 18 dead, with 12 missing and 562,000 affected. The numbers were still settling. All of the deaths were from landslides and flooding, none from direct typhoon impact. Mostly in the south, in Mindanao, where saturated ground on steep terrain does what saturated ground on steep terrain does. So here is the arithmetic, laid out flat. The strongest storm ever to hit American soil went directly over an inhabited island and injured 2 people. The same storm from several hundred kilometres away, without its winds ever reaching the country, killed 20 people in the Philippines by making it rain harder. I've turned that over for a while, and I don't think it's ironic, and I don't think it's a twist. I think it's just what these systems are, and the reason it reads as surprising is that our whole mental model of a typhoon is wrong. We picture a thing that arrives, a front door, a moment of impact, a place it hits, a place it doesn't. And that model works fine for the eye wall, which genuinely is a place, a ring perhaps 20 miles across that either goes over your house or doesn't. But the storm is not the eye wall. The storm is a moisture handling system 1,000 miles wide that reorganizes the atmosphere across an entire ocean basin. And its effects don't have a front door. They have a gradient. And that gradient reaches countries the storm has no intention of visiting and interacts with weather those countries already had. And the result can be worse than a direct hit somewhere else, because the people underneath it were never told a storm was coming, because technically one wasn't. Signal number 1 over Cagayan, and 20 dead in Mindanao, which is roughly as far from Cagayan as you can get and still be in the same country. There's a version of this where I'd tell you the lesson is, watch out for distant storms, and Pagasa already knows that, which is why they named it early and raised signals early, and it still went the way it went. The Habagat amplification problem is understood. It's been understood for decades. The issue isn't knowledge, it's that you cannot evacuate a hillside on the strength of, it's going to rain harder than usual for the next 3 days, and the hillside is where the people are, and the ground has been wet since June. Bavi also arrived after Maysak, which had come through the region days earlier and left southern China with 39 dead. The ground was already saturated across a wide area. Everything was already full. Bavi didn't need to do much. 2 injured en route at peak intensity with the eye directly overhead. 20 dead in a country the storm never touched. That's not the worst part because it's shocking. It's the worst part because it's ordinary, and it happens every season, and nobody makes a graphic about it. Right, let's follow it. Place to place, in order, because the last week of Bavi's life covers about 2,000 miles and 4 jurisdictions, and it's worth doing properly. Japan's southwestern islands, around the 9th and 10th, the Ryukyus, Okinawa, and the string of smaller islands running southwest from it toward Taiwan. Bavi went past rather than through, but by this point past is a relative term for something in the top 3% by size. It lashed them, toppled trees, and left tens of thousands of people without power, which for the Ryukyus is a Thursday. Those islands are among the most typhoon-experienced places on Earth, and their infrastructure reflects it. Tens of thousands out is significant and not, for them, a crisis. It barely made the international wires. Northern Taiwan, Friday the 10th, into Saturday the 11th. Bavi passed north of Taiwan and did not make a direct landfall. That's the sentence in every report, and it's doing a lot of work because did not make landfall is not the same as did not arrive. Taiwan's fire department reported at least 134 people injured across the island, and here's the detail that stopped me. Some of those injuries were people riding motorcycles or bicycles in strong winds, or coming off on slippery road surfaces. 134 injuries, a good chunk of them from people on 2 wheels in weather they should not have been on 2 wheels in. That's not a tale of a country failing to prepare. Taiwan prepares extremely well. They shut things down early and comprehensively. Fishing boats were packed tight in the northern ports on the Thursday. It's a tale of what happens in a densely populated place of 23 million people. When a storm's outer bands scrape past and life mostly continues. Because it has to. Because a storm that isn't making landfall is a storm you're expected to go to work in. Nobody's picture of a typhoon disaster includes a bloke coming off his scooter on a wet corner. And yet, Zhejiang, 11:20 on Saturday night. Bavi made landfall on the coast of Zhejiang province at 11:20 p.m. on the 11th. Packing winds of 144 kilometers an hour. About 90 miles an hour, according to the Provincial Meteorological Observatory via Xinhua. Then it made landfall again around midnight. Twice. Within less than an hour. That's a storm clipping a headland, going back over water briefly, and coming ashore again, which happens on a coastline as convoluted as Zhejiang's, and which means 2 separate populations got the core. CCTV described the core impact zone getting fierce winds and heavy rain, with rapid runoff forming on the ground and roadside trees being uprooted as it struck the city of Yuhuan. It was the 9th typhoon of the year for China, and it was the strongest July typhoon to strike Zhejiang since 1949. Since 1949. That's not a small window. That's the entire record of the People's Republic. And here's the number, More than 2.68 million people were relocated in Zhejiang alone ahead of it. Nationally, the figure runs to roughly 2.8 million. 2.2 million in Zhejiang in the first push, more than 100,000 in Fujian, 34,000 in Shanghai, thousands more around Ningde, then further evacuations as the picture developed. Around 1.72 million had already been moved by Saturday morning, before the storm was anywhere near. Classes suspended, work suspended, transport suspended, outdoor activities suspended, more than 400 flights cancelled in the province, dozens of train services cancelled. The National Weather Agency issued an orange typhoon alert, second highest on a 4-level scale. Cargo ships crowded into harbours up the coast in Jiangsu to sit it out. The central government released around 40 million yuan. A resident of Wenzhou called Huang Xingguan, 50, told Reuters while buying groceries at a wet market before it closed, "A little worried, but I think it'll be okay." I've thought about that quote more than any other in this whole story. Because he was right, and being right about that was not a given, and the reason he was right is that 2.5 million of his neighbours had already been moved. Rainfall exceeded 300 millimetres, about 12 inches, in places. Heavy rain over 50 mm hit about 42% of Zhejiang's total land area in 24 hours. It weakened to a severe tropical storm by early Sunday, and crossed inland into Anhui, where torrential rain was forecast to keep going through Monday, and it kept reaching. Flooding put roads under more than 2 meters of water in parts of Hebei. About 1,800 people were stranded, and rail services were disrupted in Liaoning. 46 rivers nationwide went over warning levels. Hebei and Liaoning are the far northeast. That's a storm that came ashore south of Shanghai, still causing floods most of the way to the Korean border. That's the inland reach we talked about. That's what gargantuan buys you. 0 confirmed deaths on the Chinese mainland. I want to put that next to the Philippines number without editorializing too heavily, because the comparison is uncomfortable and also not really fair. China evacuated 2.8 million people and had 0 mainland deaths. The Philippines had a storm that never arrived and lost 20 people. The difference is not competence. The difference is that China had a landfall to evacuate from, a place, a time, a cone, and the Philippines had a rain gradient. You cannot evacuate a province from "it's going to be wetter than normal for a while." One is a problem with the solution, the other one mostly isn't. Bavi crossed into Anhui, drifted north, was forecast to cross the Shandong Peninsula and enter the northern Yellow Sea by Tuesday, and go extratropical after Wednesday, which it duly did, and that's the end of it. Formed as a bit of convection east of Guam on the 2nd of July, and by the middle of the month it's a memory and a set of insurance claims spread across 5,000 miles. Right. This is the part that's still happening while you're listening to this, and I think it's the part that deserves the most time and gets the least. Rota has been without power, island-wide, since 10 o'clock at night on the 5th of July. Every single one of those 967 customers offline. That started as a deliberate act, which people find surprising. Emergency protective measures required shutting the power plant's gensets down before Bavi arrived. You take the grid down on purpose, because energized lines in a Category 5 are a hazard, and a generating plant that gets wrecked while running is a plant you cannot restart. So the island switched itself off, and then the storm came, and then it turned out there wasn't much left to switch back on. Preliminary reports from the mayor indicate that many, possibly all, of Rota's wooden distribution poles were damaged or destroyed. All of them, not a section, not a feeder, the poles. The mayor's estimate for restoration in some areas is up to 3 months. 3 months. The utility's first formal estimate, issued the following Saturday, was that restoring power to the primary main lines feeding the Rota Health Centre alone would take approximately 2 to 4 weeks, depending on field conditions, material availability, and the extent of repairs. And they were careful to say that assessments indicated severe damage to both distribution and generation. Crews started on Feeder 2, working out from the power plant. 2 to 4 weeks, for the hospital's main lines, not the island, the hospital. Water came back faster, which is the one bit of good news in this section. Repairs to the island's main waterline got service back to the majority of customers within about a week, with a CUC Water Division crew working on Rota that Wednesday. Communications are the other one. Docomo Pacific had mobile service on Rota at 14%, with the Valentino resort site the lone active tower on the entire island. IT&E had wireless coverage at about 50% on Rota, against 97 on Saipan and 60 on Tinian. Rota's VHF tower was confirmed damaged. The Coast Guard managed to get the Mount Alutum communications tower on Guam back with a FEMA generator, one tower, 14%, on an island where half the buildings are damaged and everybody's trying to tell somebody they're all right. The seaport was temporarily closed pending military and FEMA inspection. That's the navigation hazard problem again, though the mayor had authority to open a secondary port for small vessels once conditions improved. They'd used that same secondary port during the April recovery to receive donated goods from Guam. That's a detail that tells you everything about the last 3 months out there. They already had a workaround because they'd already needed one. World Central Kitchen came in providing meals through a contracted local vendor. The Red Cross worked to secure flights. FEMA personnel and volunteers started arriving on the Wednesday. Nearly 100 FEMA officials on the ground across Guam. Elsewhere in the chain it's moving faster. Saipan's power system went into what the utility called the restoration phase, with the honest caveat that there may be weak points that fail as additional areas get energized, which is exactly what a grid that took a Category 4 in April and a large typhoon in July does. Crews prioritized the water wells, the wastewater facilities, the shelters, the airport, the hospital. About 60% of water wells were back on the grid within a few days. Saipan's generation came back up to 42.5 megawatts by about day 10. And they kept getting beaten by moisture. Moisture-damaged engines, tripped feeders, rainfall limiting the ability to bring additional engines online at the power plant, slowing the whole capacity build. You can't dry a generator with enthusiasm. You wait. Guam Power had partially energized about 66% of its 67 distribution feeders and circuits by the Friday morning. Phase 2, energizing distribution lines and restoring service to customers with minimal damage, with the badly damaged infrastructure pushed to Phase 3. Which is a polite way of saying, we'll get to the people who lost the most, last. That's not cruelty, it's triage, and it is nonetheless a rough thing to be told. And the mayor of Rota, when asked for a cost estimate, said it was too early. He was at the time still seeking funds for the remaining Sinlaku recovery work. Read that sentence again. He's chasing April's money while assessing July's damage. There is no total damage figure for Barvi. I've looked. It doesn't exist yet and won't for a while, and anyone quoting you on right now is guessing. FEMA's guidance page for this, incidentally, includes a line that isn't about generators or tarps. It says that if you're feeling overwhelmed because of the typhoon, you can call or text 988 any time, and there'll be somebody there. They put that in, next to the advice about not running a generator indoors because they know that's part of it too. Second super typhoon in 3 months. Everybody tired since April. That's not a weather problem, and they knew to say so anyway. 967 connections. Every pole down. 3 months maybe. That's tonight. That's happening right now while this is on. Since we're on the subject of that ocean, let's talk about the Western Pacific itself for a bit, because it's the most productive tropical cyclone factory on the planet, and it doesn't get nearly the attention the Atlantic does. The Atlantic dominates the conversation for one reason, which is that it hits America in a way America notices. Florida is in the Atlantic Basin. Texas is in the Atlantic Basin. The entire architecture of hurricane coverage, the naming, the categories, the cone graphic, the reporter standing in a car park getting rained on, is built around a basin that produces, in a busy year, maybe 15 to 20 named storms. The Western Pacific runs about 25 to 30 named storms in a typical season, and its ceiling is much higher. Not all of them become typhoons. Not all typhoons become super typhoons, but the strongest storm on Earth in a given year is very frequently a Western Pacific storm, and the all-time records are dominated by it. Typhoon Tip, Haiyan, Yutu, now Bavi. Why here, specifically? 3 reasons, and they're the same 3 variables from earlier, just at a geographic scale. The water is warm, and it's warm across an enormous area, with the heat running deep. The Western Pacific warm pool is the largest body of consistently very warm ocean water on Earth. It's not a patch, it's a region. The atmospheric setup over it is generally favourable. Low shear across huge stretches for months at a time, and, this is the one people forget, there's simply more room. A storm forming in the far Western Pacific can have 2, 3,000 miles of open ocean ahead of it before it reaches anything. In the Atlantic, storms are frequently interrupted. They run into the Caribbean islands, they run into land, they run into cooler water, they run out of basin. Out here they can just keep going and keep tuning themselves. Bavi's entire journey from disorganized convection to the strongest thing ever to hit US soil took place over open water east of Guam. It had space to become what it became. More storms, stronger storms, more room to grow. That's the basin. The 2026 season out there had, at the time Bavi struck, produced 7 tropical cyclones. 3 had made landfall, more than a dozen people had already died, and the peak of the season, August, September, October, was still entirely ahead. Now, the bigger question, which I'm going to try to handle honestly rather than in either of the 2 directions it usually gets handled, is this getting worse? The careful answer, which is also the actual answer, has 2 parts. Part 1. The total number of tropical cyclones globally has not dramatically increased. The count is not the story. Anyone telling you there are simply more storms now is going past what the data supports. That's just true, and it should be said. Part 2. The proportion of storms reaching Category 4 and 5 intensity is rising. The strongest storms are becoming a larger share of the total, and the storms that do reach major intensity are getting there faster, holding it longer, and in some cases reaching it closer to coastlines than the historical pattern would predict. That's a different claim from more storms, and it's a much more consequential one, because the damage curve for wind is not linear. A Category 5 does vastly more than 5 times what a Category 1 does. Almost all of the harm in any given season is concentrated in the handful of storms at the top end. So a world with the same number of storms and a fatter top end is a substantially worse world, even though the headline count hasn't moved. The mechanism is the physics we already did. Warmer water, more available energy, higher potential ceiling. June 2026 was the second warmest June globally on record, according to the Copernicus Climate Change Service, running 1.39 degrees Celsius above pre-industrial levels. The Western Pacific has been running above historical averages. Bavi got very close to its theoretical maximum because the ocean it crossed had raised where that maximum sat. But here's what I'd push back on, because I think the framing does damage. Sinlaku and Bavi hitting the same tiny island chain in the same year, 3 months apart, is not evidence of anything on its own. 2 storms is not a trend. 2 storms is a coincidence, and a horrible one. And the honest thing to say about it is that the Marianas sit in the busiest tropical cyclone basin on Earth, and getting hit repeatedly is what happens to targets in busy basins. U2, 2018, Maua, 2023, Sinlaku, and Bavi, 2026. That's not new. Ask anyone over 50 on Saipan. What is new, genuinely, measurably, is the rapid intensification problem, and that's where I'd put the worry if I were rationing it. Because that's the one that eats warning time. A storm that takes 5 days to build to Category 5 gives emergency managers 5 days of escalating lead time. A storm that does it in 2 days, while still 600 miles out, compresses the window enormously. The whole apparatus we've built, the shelters, the evacuations, the concrete, everything that produced the zero on those islands, runs on lead time. It's the raw material, and rapid intensification is the thing that takes it away. Bavi didn't take it away, and that's the good news buried in here. The forecast caught it on the 2nd. Everybody had 4 days. The system worked exactly as designed. But look at what had to happen for that to be true. It had to be spotted while it was still an unremarkable cluster of clouds. 2 meteorologists had to be willing to write Category 4 or 5 in public on a Thursday about a tropical storm and be believed. The warning centre had to commit. Emergency managers had to act on a forecast rather than on weather. Every one of those is a judgment call made by a person, days before there was anything to see out the window. I'd rather not find out what Bavi looks like in a year when someone at any point in that chain decides to wait for more data. Bit of a miscellany, this one. Just the things that didn't fit anywhere else and that I couldn't leave out. The moonlight image. I opened with it, and I've not stopped thinking about it. NOAA 20's VIIRS instrument has a day-night band, which means it can image in almost no light at all. It can work off moonlight. So at 3:30 UTC on the 5th, which was 1:30 in the morning on the 6th on the ground, it caught the western side of Bavi's eye wall lit by the moon. Not infrared. Not a false colour heat map. Visible light. From the moon, off the side of a storm at its absolute peak. I think about the fact that the moon was doing that anyway. The light was already there. It was lighting up that eye wall for hours whether or not there was anything overhead to see it. The 723,000 meals. Still the FEMA number that gets me from that April stockpile. Somebody's job is to know that. There's a model and a set of assumptions and a person who signs off on the figure, and then a storm comes and either the model was right or somebody goes hungry, the wet market. Huang Xinghuan, buying his groceries in Wenzhou before the shop shut, telling a Reuters reporter he was a little worried but thought it'd be okay. The most ordinary sentence in the entire story. He's 50. He's done this before. There's a typhoon coming and he's getting his shopping in because the shop's about to close and he's going to be indoors for 2 days and he'd like to eat. 2.5 million people got moved out of that province, and the story of it is a bloke buying vegetables. The golf course. I keep wondering about Rota's golf course, which is a stupid thing to wonder about, and I'm doing it anyway. 96.7 customers, every pole down, half the buildings damaged, and somewhere on that island there is a golf course that took the full eye wall. I've not seen a single report on it. Nobody's filing that story, and nor should they, but it's there. The 1 hour, the eye covering the whole island. That's the image I can't shake, more than the satellite one. Complete calm, full daylight, over the whole of Rota at once, for about an hour, at 8 in the morning, and 1,000-odd people sitting inside listening to nothing. Phase 3. Guam Power's restoration sequence. Phase 2 is the customers with minimal damage. Phase 3 is the customers with significant damage to their power infrastructure, which means the correct, professional, unarguable engineering decision is to restore power to the people who lost the least, first, because you can reconnect 100 of them for the effort it takes to reconnect one of the others. It's completely right, and it must feel completely wrong if you're in Phase 3. Both of those things are true and neither cancels the other. 2 typhoons in a week. I'd underplayed this. Bavi was the second typhoon to strike China in barely a week. Maysak came first, into the south, and killed 39 in Guangxi with cumulative rainfall of 4 to 16 inches, and more than 35 inches in the hardest hit areas. 40 rivers burst their banks, a reservoir dam burst, 13,000 acres of farmland damaged, about 130,000 evacuated, drones and some 5,700 boats used in the rescue operation, and electricity restored to more than 60,000 homes as the water went down. 39 people, and that storm is a footnote in Bavi's coverage, because it was smaller and it happened first. Every one of these has a Maysak sitting just behind it that nobody remembers. And the thing about the forecast, 4 days, the gap between 2 blokes writing a newsletter on a Thursday and the strongest storm ever to hit American soil arriving on a Monday. Everything that went right in that gap. Nothing about this was a surprise. That's still the line I keep landing on. There was no twist. The atmosphere did exactly what the physics said it would do, on schedule. And the only reason it's a story with 2 injuries in it instead of a much worse story is that a lot of people spent 4 days believing a forecast. Everything we've talked about so far has been wind, more or less, because wind is what the numbers measure, and what the category counts, and what the warning centres bulletin. And wind is not, historically, what kills people in these storms. Water is. Storm surge is responsible for the majority of tropical cyclone deaths worldwide, and it has been for as long as anyone's been keeping the figures. Not the wind, not the flying projectiles the warning was so vivid about. The sea, arriving on land where it isn't supposed to be. Here's what a surge actually is, because it's routinely explained badly. It's not a wave. It's not a wall of water rushing in like a tsunami. That's a different phenomenon with a different cause. A storm surge is the sea level itself being raised. The wind pushes on the surface of the ocean over a huge fetch for hours on end, piling water toward the shore faster than it can drain away sideways, and the low pressure at the centre of the storm lets the sea bulge up a bit underneath it as well. The result is that the ocean is simply higher than it should be, by several feet, or in extreme cases 20 feet or more, for hours. And then whatever waves the storm is generating ride in on top of that new higher baseline. That's the bit people miss. The surge isn't the thing that hits you. The surge is the thing that lets the waves reach places waves have never reached, because it's moved the whole starting line inland. 20 feet of it is not survivable in an ordinary building in its direct path. That's not dramatics, that's engineering. Water weighs about a ton per cubic metre, and it does not compress, and it does not stop. For Bavy's approach to the Marianas, the forecast rainfall alone was 12 to 20 inches, 300 to 500 millimetres, with flash flooding and landslides flagged. Other guidance had it at over 250 millimetres, with up to 450 in places depending on how close the eye wall came. Life-threatening coastal inundation was in the warning text alongside the destructive winds. It was all there, days out, in the same bulletins everyone was reading for the wind speed. Guam ended up with that record daily total at the airport, which we've covered. The islands are steep, volcanic and limestone in places, and water moves off them fast and takes things with it. But the reason I've saved this for its own section is that the water story is the one that connects everything else in this script. The Philippines lost 20 people to water from a storm whose wind never arrived. China evacuated millions, and then had to deal with roads under 2 meters in Hebei and 46 rivers over warning levels. Water, hundreds of miles inland, days after the wind had stopped mattering. Maisak killed 39 in Guangxi with rain and a burst dam, not with wind. Sinlaku's 20-plus inches on Saipan flooded the only hospital on the island. Every genuinely lethal thing in this entire 2 weeks was water, and the number we all learned, the number in every headline, the number in the title of this very video, is a wind speed. There's no conspiracy in that. Wind is easy to measure, it maps neatly onto a scale, and the scale gives you a digit. Water is a nightmare to forecast because it depends on the terrain, the antecedent soil moisture, the drainage, the river catchments, the tide state at the moment the surge peaks, and about 9 other things that vary street by street. You cannot reduce it to a digit, so it doesn't get one, so it doesn't get the headline, so it doesn't get the fear. The one thing I'd want anyone to take from this, and I'm aware I'm meant to be helping you sleep so I'll say it gently, is that the tide table matters as much as the category. A surge arriving at low tide and the same surge arriving at high tide are different events. Same storm, same wind, several feet of difference, and that few feet is the difference between wet carpets and a fatality. Nobody puts the tide state in the headline either. Water. It's always water. 50 years of these things, and it has never once been anything else. Right, this is pure trivia, and I've been saving it, because I find the naming system genuinely charming and almost nobody knows how it works. You've probably noticed that Bavy had 2 names. It was Bavy everywhere, and it was Inde in the Philippines. That's not a translation, and it's not a mistake. It's 2 entirely separate naming systems running on top of each other, and both of them are doing something sensible. The main list is run by the World Meteorological Organization's Typhoon Committee, and here's the lovely bit. Unlike the Atlantic, where storms get human first names off a rota, the Western Pacific list is contributed by the 14 member countries and territories around the basin, and the names are mostly not people. They're flowers, animals, places, gods, weather words, stars, foods. Each member submits 10 names, and they go into a set of 5 lists that cycle through in order, not by year but continuously. When one list runs out, the next one starts, regardless of what the calendar says. Bavy is a Vietnamese contribution. It's named after Ba Vi, a mountain range northwest of Hanoi. Sinlaku is from Micronesia. It's a legendary Kosraean goddess. So the 2 storms that hit the Marianas in 2026, 3 months apart, were named after a Vietnamese mountain and a Micronesian goddess, and neither had the faintest thing to do with the islands they hit. And that's the system working exactly as designed. The list is agreed in advance and the storms take what they're given. And then there's the second layer. The Philippines runs its own list through Pagasa, and it always has. Their reasoning is entirely practical. The international names are often unfamiliar and hard to pronounce for a Filipino audience, and when you're trying to get an urgent warning to millions of people across a country that gets hit by roughly 20 storms a year, you want the name to stick on first hearing. So Pagasa assigns a local name, traditionally a Filipino given name, hence Inde, to any storm that's inside or approaching the Philippine area of responsibility, which is why Bavy was named Inde while it was still outside the boundary. Pagasa could see it coming, and the name went out ahead of it. That's a small thing that says a lot. The country whose eye wall exposure was precisely 0 was the country that named the storm early, because they knew perfectly well what it was going to do to their monsoon. Here's the other quirk, and it's the one that trips up anyone searching for this. There was already a Typhoon Bavy. In 2020, different storm entirely. It went up past Taiwan and Okinawa, and made landfall in North Korea in late August as a Category 1 equivalent, killed one person, and did about $12 million of damage. Completely unremarkable by the standards of that basin, which is why the name stayed on the list. Because that's the rule. Names get retired when a storm is bad enough that reusing the name would be distasteful, or would cause confusion in the record. Haiyan is retired, U2 is retired, the 20T20 Bavi didn't come close to the threshold, so Bavi went back in the pot and cycled round, and 5 and a bit years later it came out again attached to the strongest storm ever to hit American soil. I'd put money on that name being retired now. There's a committee that meets and decides, and the affected members request it, and I cannot imagine the Marianas or the Philippines wanting to hear it again, which means somewhere in Vietnam, at some point in the next year or two, someone will have to propose a replacement, another mountain probably, or a flower, starting with the same letter if they're feeling tidy about it. And the storm that gets it will be some cluster of clouds east of Guam that nobody's worried about yet. One last one, and then I'll let you go. Because the thing about following a single storm is that it gives you tunnel vision. You end up with a mental picture of a lone monster crossing an empty ocean toward a lone island. And that's not what the first 2 weeks of July 2026 looked like at all. Bavi was the loudest thing on the map. It was nowhere near the only thing. Start with Japan. While everyone was watching the Marianas, Kyushu, Shikoku and Central Honshu, were expecting rainfall totals over 100 millimeters across a 3-day stretch, from atmospheric moisture connected to all the activity out in the Western Pacific. Not from Bavi hitting them, just from the general wetness of the whole setup, the moisture being shuttled around the basin by a system big enough to reorganize the air over a third of an ocean. That's a serious rainfall event for anywhere. It got no coverage whatsoever because it wasn't attached to a name. Then look further west. That same fortnight, parts of India, Thailand, Vietnam, Laos, Bangladesh, and Myanmar were all dealing with heavy monsoon rainfall, not caused by Bavi, not related to Bavi in any direct sense, just part of the same broad, sprawling, moisture-heavy pattern that characterized the whole region across those weeks, the season doing its thing across several million square miles simultaneously. And meteorologists were also watching the Bay of Bengal. That's a completely different basin. Northeastern arm of the Indian Ocean, its own rules, its own list of names, its own set of countries. During the summer monsoon, it's the second most active tropical cyclone basin in the world. In the days after Bavi crossed the Marianas, forecasters were monitoring whether conditions there would support a new tropical system forming in the early to middle part of July, which would have put Bangladesh, India or Myanmar in the frame. Now think about the Bay of Bengal for a second, because it's worth the detour. It's shallow, it's funnel-shaped, it's got the Ganges Delta at the top of it, and hundreds of millions of people living roughly at sea level around the edges. A storm that would be a serious nuisance in the open Pacific is a historic catastrophe in the Bay of Bengal, purely because of the shape of the coastline and the number of people standing on the flat bit. The deadliest tropical cyclones in recorded human history, by a very wide margin, happened there. Not the strongest, the deadliest. Those are different lists, and it's the second one that matters. So, an active Western Pacific with 2 typhoons hitting China in a week, a monsoon running hard across South and Southeast Asia, Japan taking triple-digit rainfall from the atmospheric leftovers, the Bay of Bengal being watched, and sitting in the middle of it, a Category 5 crossing an island chain of 210,000 people. That is one fortnight. That's not an exceptional fortnight either. That's July in Asia, doing what July in Asia does, and I think that's the bit that reframes the whole thing for me. Because we've spent this entire video on Bavi, and Bavi is genuinely extraordinary. Record-setting, near its own theoretical ceiling, the strongest thing ever to hit American soil. It earned the attention, but it earned the attention partly because it hit somewhere with an American flag on it, and the machinery of coverage switched on accordingly. There were satellite images and warning centre quotes and FEMA numbers and a named storm and a clean narrative. Meanwhile, Mesa killed 39 people in Guangxi, and as a footnote, the Philippines lost 20 and it made a handful of wires. Japan got 100 millimeters of rain, and nobody wrote anything at all. None of those places have less weather than the Marianas, they just have less coverage. Anyway, Bavi crossed the Shandong Peninsula, went out over the northern Yellow Sea, transitioned to an extratropical cyclone, and stopped being a typhoon in any meaningful sense. which is the most ordinary possible ending, and every one of these has it. They all just become weather again, eventually, somewhere unremarkable, and then they're gone. There's no big ending to this one, and I'm not going to invent one. Right now, as this is playing, there is an island in the Western Pacific with 967 power connections on it, and every single wooden pole knocked down. The estimate is 3 months in places. The health centre's main lines were 2 to 4 weeks, and that was from a couple of Saturdays ago. Somewhere out there, tonight, there are crews working out from a power plant along Feeder 2, 1 pole at a time, in the wet, with material that has to come across an ocean. That's what's left of the strongest tropical cyclone ever recorded to strike US territory. Not the 180 miles per hour, not the 901 hectopascals, not the moonlit eye wall, a spreadsheet with 967 rows on it, and somebody going down the list. The season out there has months left to run. August, September and October are the busy part, and they hadn't started. I hope it's quiet. It probably won't be. Anyway, well, that's Bear V. Thanks for staying up with me.